Hello, and welcome back. Catching up a little bit, this is day 7, 2022. So basically for this one, we get some output of someone messing around in a terminal. Um, they There's a directory structure, and they're basically changing into various directories, listing the files. The files have sizes associated with them. So these are the possible inputs. We have cd, change directory. Cd sum identifier moves in one level. Cd dot dot moves out one level. And cd slash switches to the root directory or outermost directory. Then ls means list. And we get files and directories. And files have sizes. So you can see that given the test input, this is what the directory structure looks like. And then the total sizes of directories are the contents of the files in that directory and the total size of any subdirectories that are contained within that parent directory. And then the question is basically, find all the directories with a total size of at most 100,000 or 1E5, and what is the sum of the total sizes of those directories. Fair enough. Okay, so our input, as I've been doing for the last couple days, I'm going to first work with the test input. So this is just taken from this block of text here. And we have a bunch of commands, we have a bunch of data. I think it would be good to split on spaces. So this will just be space. Every time that I switch into Dyalog, it changes my keyboard layout. Partition right tech will, and that should be a for each. So that splits all of our lines on spaces. And then if we mix this, we get this sort of structure where the first column is going to contain, importantly, all of the sizes for our various files. And then the only command or item that actually has 3 elements is this cd change directory. So what this means is that our rightmost column has all of the inputs to our cd functions. ls, the other file directory descriptors, they don't have any entries in this rightmost column. So that's going to be helpful. Now, the first thing that I'd like to do is parse all of the file sizes. So they're numeric values, but they're strings in our input. So if we look at the leftmost column of input, this is where all of our file sizes are, along with some garbage that we don't care about for this part of the problem. So what would be nice is if we could just say, execute input to get all of the numbers. Execute in APL is sort of like eval in other languages. I think Python has eval. So it's basically trying to run these strings, and it says, hey, there's no variable, or it's an invalid token for $sign. This is a little bit janky, but one thing that we can do is we can use what's called an error guard, and that looks like this. And you can think of an error guard as sort of like almost like a try-catch statement in other languages. Essentially what this is saying is this first 0 is a code for all errors. You can catch only specific errors if you want, but I'm saying for any error that you encounter, just use the value 0. Otherwise, we're executing and we're getting the numbers. So what this gives us is a vector for all of the sizes of the different files with 0 for rows of the input where there is no size. So I'm going to assign this to S for sizes. And then if we look at the right column of our inputs, these are all of the different descriptors for the cd commands. So now if we look at our test input, we can see that cd slash only happens one time at the start of the file, or the very first line. So we don't have to bother having any sort of special logic for cd slash because it only happens once. Instead, we can sort of see that there are three possibilities for arguments to the cd function. There could be, excuse me, there could be a blank value, in which case nothing happens and we don't change directory. There could be an identifier, for example, slash A, E, D, etc. In the case of an identifier, we move one level deeper into the directory structure. And in the case of a dot dot, we move one level out of the directory structure, right? So if we look at the first character for each cell of the right column of our input, then we get this string that just has the first letter of all of these identifiers. And we could say, for the string dot space, give me the index of all of these values. And that gives you a numeric vector with three possibilities. Remember that index of, if it doesn't find something in its left argument, it will return a value one greater than the length of that argument. So we're indexing dot space, and for all of these identifiers like slash, a, e, etc., those are going to be threes. Spaces will be twos, and dots are one. Now we can then index into this with the array -1, 0, 1, like so. If you've done any sort of like problems like parentheses matching or things like that, then this will be fairly familiar to you. But if we do a plus scan on this array that we've created, then now we get a numeric vector that tells us the depth that we're in with regards to the file system at every row of the input. So we start off at the first row in the root directory slash, and then we move into A, we move into E, we pop off twice, and then we move into D, right? So I'm going to assign this to D for depth. Now, if we look at the unique elements of depth, that's going to tell us all the different depth levels that we traversed throughout our input. And if we look at D, if we look at all the levels and we do outer product equals, like so, and we'll reverse it so we get a nice shape, we get this Boolean matrix, and you can kind of see how like we start off at the top with this group of ones, and then we sink down. Actually, maybe it's better if so for each first, and put that on top. Yes, okay. So we start off in the top directory, the root directory slash. When we cd into A, we go one level deeper, and then we cd into E, and we go one level deeper still. We pop off twice, and then we go into D from the root directory. So you can see how we're sort of moving up and down these levels of depth. But what's important is that when we move down a directory, we're still considered to be within our parent directory, right? So directories sizes are the files that are contained in the directory, as well as the sizes of all of the subdirectories that it contains. So, this array is fine, but if we do less than or equals, like so, now you can see that we filled in all the ones from the top, basically. So we're always considered to be in the root directory. That's why this first level has all ones. And then in cases where we go down from the second directory, we're also considered to be in the second directory, right? Now, what's the shape of this? Shape of this is 3 rows, 23 elements each, and the shape of size is 23 elements. These are, this is a Boolean matrix, so if we break it apart, we'll get a bunch of Boolean vectors. And the Boolean vectors are the right size to partition our size vector. So what we can do is we can just say for each partition bound to size. And what this is doing is, so like if we look at our second row here, when we're 2 levels deep, we can see that there are 2 separate groups of ones, right? And the nice thing about partition is that it will group those separately with respect to size. So these are all the sizes in that first directory at level 2, and these are all the sizes in the second directory at level 2. In level 3, we only go down there once, and so we just get one partition here, right? So these are all the sizes of the files at various levels of depth. If we do for each level of depth, for each directory, add everything up, we get this, and we can just enlist it to bring all of those together. And these are basically all of the sizes of the directories, right? So we can assign this to R, and then the question asks, what is the sum of the total sizes of those directories, where they have to have size at least 100,000 or 1E5. So if we assign this to R, we can just do 1E5 greater than or equal to. We can use that to filter R, and then we just sum. And we get 95,437, which for the test input is the correct answer. For part 2, it says the total space available to the file system is 7 something, 7E7 looks like. You need unused space of 3E7, and so you need to free up enough space to do that, but you want the smallest directory that, if deleted, would free up enough space. Okay. So if we look at our result vector, this first item is always going to be the size of the root directory. And so another way that you could state this is the total size used by files and directories on the system. If we do 7E7 minus, this tells us how much free space we have, right? If we know that we have to free up 3E7 amount of space, we can do 3E7 minus. This tells us how much space we have to free up. And so we only want directories. Hang on, let me. My cat's bothering me. We only want directories that are at least this size. So we can say R greater than or equal to. And then we can use that to filter R, and we want the minimum size in that set. So that's 249,33642, which for the test input, again, is the right answer. Now this can be simplified a little bit. So 3E7 minus 7E7 minus some value could be written as, I think, negative 4E7 plus, yep, and then this can just be rewritten as minus 4E7. So just simplifying terms a little bit there. Okay, so if we put it all together, 07 video.dialog, yep. So first we got some input, And then we got our file sizes. And then we came up with our depth vector. For part one, we are calculating the sizes of all of the directories. And then for part two, we're just doing some filtering, basically. Now, if I change this and run it on the actual problem input, we get 139.1690 for part one, which is the correct answer, and then we get 546.9168 for part two, which is also the correct answer. So yeah, I thought this was a neat solution. Basically, like, if we look at our input, we didn't use this. We didn't use the second column at all. So we don't care about the names of the commands being used, the names of files or directories, any of that stuff. Basically, we just care about file sizes or the fact that we are going up or down in the directory structure. And given that, we're able to use partition to get the sizes for each of the directories at every level of depth. So that's the entirety of part two, 5 lines. Alrighty. Yeah, thanks for watching.